Literally.
I is my micro good? Okay, let's start today. We're learning the grids in CSS with AI's help. So I'm gonna create a beautiful grid.
for the grid template columns and grid template rows. We could use a 3x3 grid, for example. Later I will show you how to make this completely automatic. And now, in grid template areas, I create a design that looks somewhat like this. We are just rearranging the 5 grid areas for the 5 boxes so that we have a 3x3 layout. This is now a bit thinner, and grid areas for the 5 boxes so that we have a 3x3 layout. This is now a bit thinner and perfectly suited for tablet devices. And of course, the same thing goes for mobile screens. I can do the same thing again, but this time with only 2 columns and 4 rows. So depending on the screen size, we can always change the grid template areas property to create a grid layout that fits properly. But you might have noticed one annoying thing. We always need to change grid template columns and grid template rows. But I found a way where we don't need to change these properties. There's a solution where you only adjust the grid areas and the columns and rows will follow automatically, because technically that information is already contained in grid template areas. So I will remove grid template columns and grid template rows everywhere, and only at the beginning, up here in my grid container, I will use different properties. I'll create an implicit grid. That means auto rows. These properties will now create an implicit grid. That's 200 pixels. By using these properties, we don't need to specify the columns and rows anymore, since they will be created automatically. I'm not saying that this is the better way. If you really want to be 100% sure, and you want more control over the individual columns and rows, then you will be better off with grid template columns and grid template rows in the media query. But if you prefer a shorter and more automatic way, then do it like this with an implicit grid. Now there are a few things to consider going forward. Right now I'm using a fixed unit. You could also use the unit EM, which is a bit better, but with both of these units, you're limiting the size of the bubble. This is why we have to make a decision. Do you want to hide overflowing content with overflow hidden and make sure the grid stays in place perfectly, or do you want to have an adaptive grid that resizes itself based on the text content? For that you can use the value auto or 1 fraction for the automatic rows. But what is the difference? The value auto is dependent on the text content. Here, if there is no content or padding, then there is no row. If there is more text content, the height of the row will adjust automatically. But I think this will make it really difficult to balance the layout, because now the content has to be balanced perfectly to make this grid look a fraction. That if I start filling the first row with a bit of general rec with images and cool amount of info, because most with too much text. The goal is to make a product look awesome and not to present a big amount of information. Now before we move on to my favorite way of using grid layouts, where we create a responsive layout for an online shop, let's talk about a topic that shows how you can use grid in a completely unexpected but powerful way. Because so far we've only used grid to create responsive layouts. But grid is actually more powerful than that, because we can use the same properties to solve completely different problems too. For example, if you want to stack certain elements, like when you want to place text on top of an image, or put a video behind a website section, then you would use a concept called grid stacking. It is entirely possible with the grid properties you already know. You just have to get a bit creative. Here's how it works. When you have a grid layout defined, you can target the child elements and use the properties grid row and grid column. These properties control how many columns or rows an element should span. For example, if I set grid column to 1/3, the element stretches across 2 columns, because grid lines are counted 1, 2, 3. Now, why am I telling you this? Because we can use this exact concept to make child elements overlap. Let's assign the same cell in the middle to our second child, by making it stretch from line 2 to line 4. By default, that will push it into another row. So we also have to set the same grid row, 1/2, and do that for both child elements. Now you can see how they overlap. It is even clearer if I lower the opacity on one of them. So when 2 elements share the same grid cell, we essentially get the same behavior we want from absolute positioning, overlapping elements that are positioned relative to their parent. A common example for this would be to place text on top of an image. With absolute positioning, you would have a wrapper with position relative and a text container with position absolute, and then use the top left bottom right values to position it exactly where you want it. This works totally fine, but here's the same thing with grid stacking. Remove all of this and instead set the wrapper to display grid. This will automatically create a 1x1 grid without defining rows or columns, where grid overlap place as you would have stacking the sample. Imagine you want to play a With absolute positioning, you would often have to set either the video or the text content to position absolute. That will work fine, but if the content size changes dynamically, you could run into some ugly overflow issues. But with grid stacking, you don't have to worry about that. Let's remove the absolute positioning and set the header to display grid. This time I will use grid template areas. I simply define one area and call it stack. Now on both the video and the text container, I assign that grid area, stack. It is very readable and you can see how both elements stack in the browser. Now to control which element is on top, I just use the Z index property. The higher the value, the closer the element is to the viewer. And again, we can center everything with place items center. Very intuitive. Alright, so far we can center everything with place items center. Very intuitive. Alright, so far you should already have a good understanding about the properties we have in CSS Grid. But the most important grid concept is still missing. The one concept that is used in most real-life applications, a concept I call grid wrapping, where the grid is able to adjust the amount of columns that fit on the screen at once. If there is not enough space, it will simply eliminate a column and put the items into the remaining columns. It is doing all of this automatically, responsively, without any media queries. And to learn about this concept more practically, let's implement it into this basic online shop layout. We want to create a wrapping grid that shows these products in a responsive way. Depending on the screen size, the grid will automatically add or remove columns, so that the website looks great on any device. Let's take a look at what we have got so far. We have a basic website with a products list. These products are simple div containers with an image, a name, and a price. That's it. They have very basic starts, display flex and flex direction, and column to have a vertical layout within the containers. The image has a height auto-applied so that the height can resize properly if we change the size of the image using grid, which we will do. So let's take a look at the grid layout. In the product list, we have of course display grid. The columns are pretty basic, just 3 columns, each 300 pixels. In the browser, that means this grid is not responsive. If I resize the window, these columns will overflow. To calculate how many columns can fit automatically, we have to use a function called repeat. This function is pretty powerful. It takes 2 arguments. The first one determines how many times you want to repeat, and the second one, what value you want to repeat. For example, I can say repeat 3 times 300 pixels. Then that would be exactly the same as before, just using the repeat function. If I say repeat 4 times, it will create 4 columns of 300 pixels. So far, pretty simple. But we don't have to use a fixed number value here. We can also use the keyword autofit. Then it will check automatically how many times we can repeat the value 300 pixels depending on how much space there is. So if I resize the browser window, you can already see how it will create and delete columns depending on more risk. There's not enough space. We could make that. We have to adjust the second parameter. Here, we provide a size range instead, using the min-max function. The minimum value should be 300 pixels, but the max value should be 1 fraction. So essentially, we're telling the browser, try to autofit as many columns next to each other as possible, and each column should be between 300 pixels and 1 fraction wide. That way, there is no white space, and we end up with a responsively wrapping grid where the columns can resize if needed. Pretty awesome. And with that, you have just completed an entire deep dive
Is my micro good?
into CSS Grid. But we can also use the keyword autofit thing with grid stacking.
Okay, let's start today our learning the grids in CSS with AI's help.
Remove all of this and
I'm gonna create a beautiful grid.
instead set the wrapper to display grid. Don't need them. Now on the text container, set both grid column and grid row to start at line 1 and end at line 2, meaning it covers the entire grid, since this is only 1, 2. On the image, we do exactly the same. Grid row and grid column 1, 2. Image that we now have the elements at the start, translating it back as you would have to do The position property in CSS can assume 5 possible values. Static is the default value and will have no effect on the element. But when you assign any of these other values, then you can use the properties top, bottom, left, right and z index to position your element exactly where you want it to be. If you assign position relative, then we can use these properties to offset the element to itself. What does that mean? You can change the position of this element relative to its normal position, meaning it will be positioned relative to the position where it would be if the element was static. Declaring top 30 pixels and left 30 pixels will offset the element by 30 pixels from its initial top and left value. That means it will be pushed down and pushed to the right by 30 pixels each. Declaring higher values will push the element further away. You can also use bottom or right, but that would push the element out of screen, as we are always pushing the element away from its static position. Position fixed will fixate the element to the window. That means if we have a scrollable website, then an element with position fixed will follow the user around, because the element now sits on another stacking context, meaning the element is basically on another layer above everything else. Now the properties top, left, right and bottom work differently. They are no longer relative to the element itself, but rather to the entire window. If you set the right property to 0, then it will be 0 pixels away from the right edge of the screen. Top 0 will position the element 0 pixels away from the top edge. The interesting thing about fixed positioning is that now you can also use percentage values. For example, we can try to center the element on the screen by setting its top and left value to 50% each. Looking at the result, we can see that in a way the element is centered. At least its origin, which is the top left corner of the element, that is centered. But we want the element center to be centered. For that, we need to adjust its transform translate. We need to push the element back by 50% relative to its own size. Meaning translate negative 50% for the x-axis and negative 50% for the y-axis as well. And there you go. This is how you center an element using fixed positioning. This is, by the way, what these annoying pop-ups use when they want you to accept the cookies. Now let's talk about position sticky. This one is very special. A sticky element behaves just like a normal element, but when inside a scrollable website or container, the moment the element hits a specified position, it will stick to that position like a fixed element would. As we can see, the element will now follow us around on a new stacking context, exactly like a fixed element. The only difference is that it is not always fixed, but only when it reaches that sticking point. Where exactly that sticking point should be can be specified using top, left, right and bottom. The next position value is position absolute. This is by far the most important position. An element with position absolute will always be positioned relative to its nearest ancestor that has a specified position. Let me explain. Here we have a parent and a child element. The child element has a position of absolute. To position the child element within the parent element also needs to have a position value. The best value to use here would be position relative, as this position value has almost no impact on the element when we are not changing anything using top, bottom, left and right. Now our child element can be positioned relative to its parent. Top 0 and right 0 will position the child in the top right corner of the parent. If we don't have position relative applied to the parent element, then the absolute element will be positioned. If we don't have position relative, understanding absolute positioning that I put inside the search bar, or inside other elements. Like this button, for example, that I put inside the search bar. All you need is position absolute on the child, and then use position relative on the parent element. This will now be your reference point. Now you can use top, left, right and bottom to position the element inside that element. But be aware of the fact that an absolute positioned element will be in a new stacking context. This means that just like a fixed positioned element, an absolute element will cover the other elements of the website. The cool thing here is you can actually control the order of these layers by using the z-index property. If you assign negative values, you can put the element behind other elements. If you assign a higher value, the element will be above the other elements. This will be useful for a navigation bar, a sidebar, an overlay, or a pop-up, for example. All of these elements should have a higher z-index than the rest of the website. This was Coding to Go. And if you learned something new today, like and subscribe.
Possible with transitions. If I want multiple steps and full control over the animation, I needed keyframes. First, to create an animation, remove the hover effect and the transition property, then write the keyframes rule. To define the stages of the animation, I can use 0%, 25%, 50%, and 75%. I'm choosing 4 steps because that's all I need for this animation. But you can use any percentage you want, like 20% or 10%. The percentages don't have to be in exact order. That's the flexibility of keyframes. Now let's define what happens at each stage of the animation. At 0%, I don't want anything to change, so I'll write transform translate 0, 0, so the box stays in its original position. At 25%, I want the box to move to the right, so I'll use transform translate 300 pixels, 0. This moves the box 300 pixels in the X direction while keeping the Y position the same. To make the animation work, we need to apply it to the box. For that, we add 2 properties, animation name and animation duration. I'll set the animation name to move box, you can use any name you want, and set the duration to 3 seconds. If the animation doesn't run, make sure the name in animation name matches the name inside the keyframes rule. Once the names match, the animation will work correctly. Want to learn more about CSS animations? Check out our full CSS animation video. At 50%, I want the box to move to the bottom right, so I'll set both the X and Y values to 300 pixels by writing transform translate 300 pixels, 300 pixels. Now you'll see the box move to the right first, then go down to the bottom right, and after that, it starts moving back up. For the final state, I'll write transform translate 0, 300 pixels. This moves the box back to the left while keeping it 300 pixels down. Now the animation is complete. We've created this movement step by step using keyframes. Here, I'll also add a 100% state. It will be the same as the 0% state, and to keep the code clean and short, I can combine both states using a comma. Now you can see the animation works properly. Next, I've already defined 2 important properties. The animation name tells the browser which keyframe's animation to use. The animation duration defines how long the animation takes to complete one cycle. If you set it to 0 seconds, the animation won't run. Next is animation timing function. It controls the speed of the animation and works just like transition timing function. If I use ease in out, the animation starts slow, speeds up in the middle, and slows down again at the end. Then we have animation delay, which sets a delay before the animation starts. For example, if I set it to 2 seconds, the animation will wait 2 seconds before playing. Finally, animation iteration count controls how many times the animation repeats. You can set it to a specific number or use the keyword infinite to make it run forever. Next is animation direction. It controls whether the animation runs normally or in reverse. By default, it's set to normal, which means the animation plays from the first keyframe to the last. If you set it to reverse, the animation starts from the last keyframe and ends at the first. If you use alternate, the animation plays forward first, then backward. And with alternate reverse, it plays backward first, then forward. Now let's talk about animation fill mode. I'll add another keyframes rule and make sure the animation name matches the keyframe's name. In this example, I'll define 2 states where the box moves from -400 pixels to 300 pixels. If I use animation fill mode forwards, the animation stays at the last keyframe after it finishes. If I use backwards, the element applies the starting keyframe styles before the animation begins and returns to its original state after it ends. If I use both, it applies both the forwards and backwards behavior. Finally, we have animation play state. This property lets you pause and resume the animation. It accepts values like running and paused. If you want to pause the animation on hover, just add a :hover state and set animation play state paused. All of these animation properties can be used individually, or you can combine them using the shorthand animation property. This allows you to write everything in a single line, keeping your CSS clean and concise. Now I want to animate this box in a circular motion. To do that, I'll create another keyframes rule and name it orbit. In this rule, I'll define two states, from and to. The from state represents the start of the animation, which is 0%, and the to state represents the end, which is 100%. Inside from, I'll set transform rotate 0 degrees, and inside to, I'll set transform rotate 360 degrees. Then I'll update the animation name to orbit so this animation runs. Finally, I'll set border radius 50% to make the box a circle. Now the animation plays in a circular motion, although the rotation might not be very noticeable. Now I'll remove the animation from the box and apply this keyframes animation to the container instead. I'll also set border radius 50% to make the container a circle. Now you can see the animation looks like an orbit, moving in a circular path. If you've seen this kind of animation on websites, this is usually how it's built. There are two ways of creating animations in CSS: transitions and animations. Transitions let changes in a property happen gradually instead of instantly. Without transitions, any changes in a property would happen right away. For example, imagine a button that changes color when you hover over it. Without a transition, it would switch colors instantly. But with a transition, it changes color smoothly over time. Animations give you more control with keyframes. This means you can create detailed, step-by-step animations. For example, think of an element that moves and then its shape changes. With animations, you can define each step of this movement. You can create this type of amazing effect by using both transitions and animations together. To make this button animation, check out our older video. Let's get started. CSS animations. It enables you to create complex animations that progress through multiple styles over time. They're defined using the keyframes rule, which allows you to specify the styles at various points during the animation. You can control the timing, duration, and other aspects of the animation using animation properties, but more on those later. The keyframes rule in CSS animations is incredibly powerful, allowing for detailed specification of an animation's behavior at various stages of its execution. You're not limited to just the start from and end to points. You can specify any number of intermediate steps, called keyframes, to create complex animations. Each keyframe can define the CSS properties to apply at that specific point in the animation timeline. This example demonstrates one animation that changes the color of an element through multiple colors over the animation timeline. Let's create an animation. The transform property in CSS is used to apply geometric transformations to an element, such as moving, scaling, rotating, or skewing. You can do many things with the transform property, but here is a short description of the most common ones. Translate: moves an element horizontally and vertically. Scale: scales an element by a specified factor in the horizontal and vertical directions. If you specify only one value, it scales both directions equally. Rotate: rotates an element clockwise from its current position. Here, the element moves 100 pixels to the right and 100 pixels down from its original position, and then rotates 45 degrees clockwise. The transform property is often used in conjunction with animations and transitions to create more dynamic and visually appealing effects. If you don't know all the CSS transform properties, then watch these videos. Click on the I button or check the links in the description. By combining keyframe animations or transitions with transformations, you can create complex, smooth animations that enhance the user interface of a web page. For instance, let's add a hover state that moves our element and rotates it 135 degrees when we hover. Initially, this change takes effect immediately. To make it smoother, we can use the transition properties. Here, we use the transition property with the name transform. Set the transition duration to 1 second, the transition timing function to ease, and the transition delay to 0 seconds. To smoothly change the background color of the element, add it to the transition property. So, to apply two properties simultaneously, combine them into a single property with multiple values. Instead of using these four properties separately, we can use the shorthand transition property. This works great, and we can shorten our code even more if we have a delay of 0 seconds. If you don't know all the CSS transition properties, then watch these videos. Click on the I button or check the links in the description. Let's create an animation. To create an animation, we first need an element that we want to animate. I have an element with the class of box. To animate this box in the CSS file, I will add a keyframe. The syntax for this is to use keyframes followed by the name of our animation. I'm going to call it an example. We define the animation. I want my box to move upwards and rotate on the screen, then return to its original position. To do this, I need to define the rules from the beginning to the end of the animation. I can add the two values from and to. From represents the beginning of the animation, or 0% completed. I want the animation to start at 0 pixels in its original position and move to -100 pixels upwards and rotate. So inside from, I will add a transform of translate y 0 pixels and rotate 0 degrees. I set this to 0 because it will bring the element back to its original position. To represent the will add a degree. Looking at our box, we see nothing is happening. This is because we haven't applied the animation to our box. To do this, we need to add the 7 animation properties to the .box class. Animation name, animation duration, animation timing function, animation delay, animation iteration count, animation direction, animation fill mode, and animation play state. Animation name specifies the name of the keyframe animation that should be applied to the element. Animation duration determines the length of time that an animation takes to complete one cycle. It's defined in seconds or milliseconds. Animation timing function defines the speed curve of the animation, which controls how the animation progresses through its duration. Common values include linear, ease, ease in, ease out, and ease in out. Animation delay sets a delay before the animation starts, allowing you to offset when an animation begins. Like duration, it's specified in seconds or milliseconds. Animation iteration count determines how many times the animation repeats. It can be a specific number or the keyword infinite for an endless loop. Animation direction defines whether